Hello, everyone. I'm Dan. I'm the General Relations Specialist of Electronics, Smart Cities, and GLPAE. So, as I was saying, I'm Dan. I'm the General Relations Specialist for Electronics, GLPAE, and Smart Cities. And I welcome you to the second part of the MDPI World Cities Day 2025 Session 1. I will share with you some information about MDPI. We are an open access pioneer, open access publishing. MDPI has supported academic community since 1996. We are based in Basel, Switzerland, and we have the mission to foster open scientific exchange in all forms across all disciplines. Our 491 diverse and open access journals, including 482 peer-reviewed journals and 9 conference journals, are supported by more than 2,900,000 academic experts who share our mission, values, and commitment to providing highly quality services for our authors. Here are some information about the journals related to our webinar today. Applied Sciences, which is a peer-reviewed open access journal on all aspects of applied natural sciences, published semi-monthly online by MDPI. Atmosphere is a peer-reviewed open access journal of scientific studies related to the atmosphere published. It is published monthly online by MDPI. Automation, as well, is an international peer-reviewed open access journal on automation and control systems, published quarterly online by MDPI. Here we have relevant special issues regarding our webinar today. The 3D city modeling and remote sensing, advances, challenges, and new technologies, the second editions. Our editors of this special issue is Dr. McAway, Dr. Hijazi. The next one will be innovations in sustainable construction and road engineering materials, with the special editors being Professor Sheng and Professor Yu. And the last one will be Smart Cities and Sustainability, Advanced Technologies and Future Challenges. Special issue editors, Dr. Xu, Dr. Li, Dr. Wu, and Dr. Pen. Here is our program for the second session 1. So each speaker will have 20 minutes at his disposal in order to present their works. After that, we will have a Q&A session of 20 minutes, and of course 5 minutes to close the web. One last thing before I present the speakers. So regarding the Q&A box, so if you have any questions during the presentation of each speaker, please write it down in our chat box. And after each speaker ends their presentation, I will start reading all the questions in the chat box. And after that, if there are any other questions, you can raise your hand and you can speak afterwards. So the first speaker of today will be Professor Philip Mora, but unfortunately he has some health issues at the moment, and unfortunately he cannot attend today. And I hope he will get better soon. And I will go next to our next speaker, Dr. Vasiliki Asimakopoulos. So I will make a short presentation. So she is a civil and environmental engineer with a PhD in urban air quality and, sorry, second. Yeah. So as I said, she is an urban air quality and environmental modeling PhD from Imperial College University London, UK. Her research is focused on the following subjects. So the first one will be development of anthropogenic and biogenic emission inventory at national and local level. Second one, application of photochemical modeling systems over urban, national, and regional areas for the study of physiochemical processes and for the evaluation of parameters that determine air quality. Third one, targeted monitoring studies of the air quality and wind flow patterns in scaled city models, as well as in indoor and outdoor urban environments using specialized and state-of-the-art equipment. Or application of microscale models for the study of the characteristics of dispersion of pollutants emitted in the urban environment. 5, integrated study of the total personnel exposure to the pollutants in urban environments. And lastly, promotion of practices for environmental protection, health, and climate change mitigation to the public and stakeholders. Dr. Vasiliki, I will stop the screen share. And if you can start sharing your screen.
Thank you very much for the opportunity to present my latest work on the subject of urban air quality. I'm presenting the results of a project funded by the General Secretariat of Research and Innovation from Greece, a nationally funded project called Fair City, whose scope was to develop a small, innovative, smart city air quality monitoring network by taking advantage of smart benches that offer a variety of services. This project was driven by the needs to understand how people are exposed to air pollutants at the level which they live, work, circulate, and to see firstly. And secondly, it was driven by the citizens' need to be more informed concerning their local air quality, more informed concerning the protection of their health against high air pollution levels, and to raise in general their awareness concerning their impacts, their personal impacts on the environment by their activities, as well as how this comes back to affect their quality of life. So this is a small project that is the beginning. And actually right now we are in the process of expanding this network I will present to you with more stations and with more pollutants. So this, I come from Athens, Greece. The National Observatory of Athens, where I work as a researcher, is located in the region of Attica, which is at the northeastern part of the Attica region, which is shown in this figure here. The stations were located at various municipalities inside the Attica region. And to give you a brief introduction of the situation, the current environmental situation in our region, it hosts the capital of Greece, Athens. It is the most populated region of the country with almost 4 million people. Almost half of our country's population works and lives in Attica. There is a dense concentration of sources, of anthropogenic sources in the region that come from traffic, from transportation with cars, buses, and so on, from residential heating of residences, of the tertiary sector, of restaurants, of hotels, and so on. And there are two main industrial zones located at the west of the capital, Athens, over here, and a smaller one at the northeastern part of the Attica region, which under certain meteorological
Sorry,
conditions,
Dr. Vasiliki, sorry for
yes,
interacting, but unfortunately the slides are not moving. I only see the first
oh,
slide and I don't
oh,
see the
sorry,
presentation. It's fine.
sorry, I will stop and share again.
Yeah,
Sorry.
yeah, that's fine. No worries. It happens. It happens. We have some
Thank you.
technical issues here. No
I
issues.
understand. Yeah, I understand. Okay, let me see. Can you see now
Yeah,
my slides?
now it's
The big.
perfect. Yeah.
Okay, thank you. Maybe I have to exit the presentation mode from the. We will see. So now you can see the Attica region. This is where the country's uh, capital is located, Athens. Here are the two main industrial zones. And inside the greater Athens area, as we call it, we have a big concentration of anthropogenic activities, traffic, port activities, residential heating, and industry. Under certain meteorological conditions, with the aid of strong temperature inversions, we have trapping of pollution inside the greater Athens area, and at the sea area at the south of the city, which poses a problem as emissions continue as business as usual. The temperature inversion does not let the pollutants disperse, so they keep concentrating above the general area, and we have pollution episodes. Several measures, including new technology cars, restrictions in the heating devices of countries, and energy upgrading of residences have helped to improve the situation. However, the meteorological conditions are really impacting seriously our area. So the main pollutants that affect our area are particulate matter, 10 micrometers and 2.5 micrometers, nitrogen dioxide, and ozone. These are the main pollutants, which also have an effect on the health of the citizens. Now, I have moved to another slide. If you cannot see it, I will have to try a different
No,
method to
we
present.
see it. Now it's good.
Okay.
Now it works.
So this is how, excellent, thank you. So this is how we monitor, the Ministry of Environment monitors air pollution in the greater Athens area. There are some stations, they are the official network of the country. They are regularly reported to the European Union as the directive of air quality mandates. And based on this information, the Ministry of the Environment extracts the daily air quality indices, which help the citizens identify whether the air quality is good or not good. In certain cases, some announcements are made, public announcements, warning the population of imminent dust intrusion events from Sahara Desert. We are quite close to the Sahara Desert geographically, and under certain meteorological conditions, we experience dust intrusion events, which in some cases are really severe. And we see PM concentrations above 1,000 micrometers per cubic meter, which is like really very, very bad, as you all know. But the official air quality, excuse me, that operates is not dense enough. And the location of the stations is on rooftops of buildings. So we don't really know what happens at street level where the citizens work and live. So this is what we are trying to do in this project, contribute to this monitoring with stations located at different areas in order to touch the citizens, to see really what goes on. Several research groups have started to develop research low-cost monitoring networks. For example, the figure on the right is from the Panakia network. It's a research network. It only monitors PM 2.5 concentrations, but it's a good start to give us an indication of how the air quality is formed inside the Greater Athens area. So, going back to our project, the Fair City project, the idea was to put together smart city services that come from the smart benches that offer free internet connection, free wheelchair and devices charging. Excuse me. These the wheelchair chargers are unique in our country, and people who have wheelchairs have access to a free application, and they can charge their wheelchairs for free if they have this application. And so we put the smart benches with air quality sensors in order to attain the continuous air quality monitoring at the level where the citizens live. Now, the air quality, this is a picture of the first actual smart station that monitors also air pollution in a densely populated municipality of southwestern Attica, close to the port, to the Athens port of Piraeus, which is the busiest port in our country. This bench is also for sitting. This is the location where the wheelchair users can come and charge their wheelchairs. You cannot see now, but there is a screen on the inside of this column and a screen on the outside of this column. This screen is used by the municipality to communicate anything it needs to its citizens, so it's for announcements. And the screen that cannot be seen from the inside is the one that depicts the current air quality conditions in the area. The smart sensors are located over here at the top part of the photovoltaic panel, which extends along the roof. They are positioned in such a way as to make sure that the airflow is free, so they can pump in air and give accurate as much as possible measurements of the air pollutant concentrations. And also it is protected from weather phenomena and not visible to anyone, to the public, as you might know, it's common in our country, maybe not in yours. There are people who would like to vandalize benches, who would like to steal anything they can from the the structure as a whole, cables, anything you can imagine. So this is a really robust structure. Uh, we have taken all precautions we could in order to avoid any theft of instrumentation and to ensure its continuous operation. This is what I told you before, where the sensors are located, and this is a picture from the inside of the benches. Since we are talking about low-cost sensors and not official sensors such as those that the ministry operates, we we took them. It's these devices here, the white square ones. We took the devices and put them for 2 or 3 weeks to operate next to instrumentation that is regularly calibrated and certified. And we trust their measurements in order to compare, and in case it is needed, to apply an algorithm to correct the low-cost sensor measurements and thus produce as accurate as possible data. The pollutants that are monitored are monoxide, carbon dioxide, um, NO2, SO2, ozone, PM10, PM2.5, and PM1. And the meteorological parameters monitored are used by us to ensure that the sensors operate correctly. They are not used as official measurements of meteorology. So what happens then? This bench started operating. The sensors started monitoring the air. Firstly, the data by these low-cost sensors operate with the aid of a cloud. So we can see all of them inside a platform that we have access. From this platform, we pull the data to a local platform located here in the National Observatory of Athens, where we perform some quality checks. The quality checks have to do with taking out any data that are erroneous, such as negative values, such as extremely low consistent values below the the range of operation of the sensor. And then this information is translated into hourly values. The sensors send measurements approximately every 5 or 10 minutes. So we translate the quality control values into hourly averages, which are then used to compute the air quality index value based on the equation to compute it given by the European Union. And then based on the AQI of each pollutant, we select the worst AQI, and this AQI determines the overall air quality level of the area. So far, we have seen that the pollutants that mostly drive the air quality index in the areas where we have installed the benches are ozone and PM10, which means ozone is a secondary pollutant. It is mainly formed after the emission of NOx, of nitrous oxides that come from traffic mainly, and port activities. And this is transformed with the photochemical cycle into ozone based on several conditions such as temperatures, high temperatures, and intense solar radiation. So it's a problem of the country in general and of Athens that occurs in the warm months of the year. On the other hand, PM10 are mostly high during the cold months of the year, since in Athens we have a huge number of houses burning biomass to heat, because unfortunately heating oil is quite expensive and many households cannot afford to buy heating oil. So biomass burning is a cheaper way to heat your house, as well as during dust intrusion events. So these two pollutants are those that drive the air quality of the greater Athens area and of the monitoring stations that we have so far developed. This is what the citizens, sorry about the Greek, all screen information is given in Greek since we are in Greece, but this is what the citizens can see on their screens. So this is something like the air quality index rainbow, let's say, as the far left, the green, indicates very good air quality. The far right, the dark red, indicates very bad air quality, dangerous conditions, and people with or without health problems should avoid going out, should avoid any type of exercise or intense activity to protect their health. Any indication in the orange or light red areas is a medium air quality, which requires only people with health issues to take care, consult their physicians before performing any outdoor activities. In case there is a dust intrusion event, this rainbow disappears and the citizens only see a warning with big font letters, dust intrusion event, please consult the Ministry of the Environment and the Ministry of Health in order to see what you must do. So, since we are researchers, we did not stop at the smart stations. We have started to collect the data in order to compute the risk on public health. So what we have done is, after collecting data from the smart stations, we use from the literature exposure response functions to estimate the exposure, and then we apply the AirQ Plus software that was developed by the World Health Organization. So it's free, it's public, anyone can use it. We insert the data that have to do specifically with the population density of the area we are interested in, with the characteristics of the population, with any other socioeconomic data is required, plus the air quality, to compute the risk on public health. So this is the first city network. So far, we have 5 smart stations that operate across Attica. So far, we have found that the air quality conditions are quite similar across the greater Athens area, because the type of sources and the type of environments is similar, with some exceptions that have to do with those municipalities that are closer to industrial zones. Right now, we will expand this network with 10 more new stations. We hope by the end of the next year, they also will be operational. And we are collecting our data, and in the near future, we will have approximately 1 year of data, so we will be able to publish some more detailed results and conclusions regarding the risk to the population, as well as measures for the future. Closing this presentation, I would like to thank you for your attention. I would like to remind you that this is a project that is targeted towards the public. We want to raise awareness. So our message to the public, but to everybody, is we must protect our health and the environment. These two go together. When you protect your health, you protect the environment. Not big changes can be done, but awareness must be raised, and we must be in good communication and collaboration with the local authorities who are also interested in the welfare of their citizens. And with this, I would like to thank you for your attention.
Thank you too, Dr. Vasiliki, for this very informative presentation and for all the work you do for improving the health benefits in, of course, in your cities. If everyone has any questions, if someone has any questions for Dr. Vasiliki, you can raise your hand or you can just write your question in the chat box. Okay, I think we can move forward. I think we will leave all the questions for the Q&A session. So thank you again, Dr. Vasiliki, for your presentation. Now I will on my screen. So our next speaker is Dr. Sahara, which is a senior lecturer at the University of New South Wales, Sydney, Australia, and serves as the co-convener of the Smart Cities and Infrastructure Cluster in the School of Built Environment at the same university. She's areas of research include technologies relevant to the built environment, include advanced GIS and the BIM, the sensing technologies, digital twins, and artificial intelligence for applications in sustainable and resilient cities, smart cities, infrastructure, urban strategy development, and construction. He's currently serving as an editorial board member for Nature Scientific Reports, Sustainability and Buildings, MDPI journals that are all in Q1. Dr. Sarah, if you can share your screen.
Sure. Hi, everyone. Thank you very much for your invite to this really valuable session. I am learning from other speakers as well. Thank you, Dr. Vasiliki. It was a really interesting project. I really enjoyed learning about the project. I'm going to share a screen. Just give me a moment, one moment. Okay, I'm sharing the whole screen if it is okay. Is that okay if I share the whole screen?
No, we cannot see the screen yet.
Okay, okay. Thank you everyone for coming to this presentation. I think I am introduced, very well. I just want to tell you, I'm going to talk about geospatial thinking for sustainable development goals, and I have grouped, the kind of the kind of papers I have published where we have used any geospatial method, GeoAI method for achieving sustainable development goals, or to identify some issues, problems relevant to sustainable development goals. And I'm going to, discuss today, what is the value of geospatial thinking for, for this kind of sustainability studies. Please feel free to contact me via LinkedIn if you like later. I think I'm introduced very well, but I just want to let you know that I'm also very interested on GeoAI, which is intersection of AI and geospatial analysis. And nowadays, we are working a lot on this topic with our students and researchers at the University of New South Wales. University of New South Wales, UNSW, is one of the top ranked universities in terms of sustainability. It's, the university kind of supports sustainability topics, invests on sustainability topics, and has achieved, so far reduction of, for example, greenhouse gas emission by 30%. And there are some other targets that relevant to sustainability that UNSW has achieved, and it's ranked top 12 globally. And as part of this university, I am also very interested on using the technologies that I am teaching, or I am implementing, or I am developing or integrating for for sustainable development goals. I have added some initial definitions or introduction regarding sustainable development goals. I'm sure everyone knows what is sustainable development goal, but I felt it's really valuable if I add some introduction. So if sustainable development goals are universal call to action to end poverty, protect the planet, and improve the lives and prospects of everyone and everywhere. So it's kind of also thinking not only about ourselves, but also about our future generations. So there are 17 sustainable development goals introduced. Among these sustainable development goals, the ones that are most relevant to cities and relevant to the areas of my interest to kind of conduct research are, sustainable development, goal 11, which is sustainable cities and communities, sustainable cities, resilient cities and communities, sustainable development number 7, which is affordable and clean energy, sustainable development 13, which is climate action, and I think there are some other okay, number 3, good health and well-being, sustainable development 3, good health and well-being. So we have worked on some of these sustainable development goals. We have used some kind of geospatial thinking to better understand what is going on and how we may kind of identify areas where we need more intervention policies, plans, or projects. So sustainable development goal number 11, which is sustainable cities and communities, it's the aim is to make cities and human settlements more inclusive, safer, and more resilient and sustainable. There are some targets for each of these sustainable development goals. I'm not talking about all these targets for all these sustainable development goals that are of my interest, but I just want to show you some of these, for example, targets for sustainable cities and communities that include safe and affordable housing, affordable and sustainable transport systems, protect the world's cultural and natural heritage. And for example, another one is reduce the adverse effects of natural disasters, reduce environmental impact of cities, and so on. And yes, there are other targets, around 10 targets for Sustainable Development Goal 11 only. And we have, this kind of targets for other sustainable development goals. Now, the question is that considering the limitations of our available, resources, can we really achieve all these goals on all places? And if not, what should we do? And in the area of my expertise, usually the answer is to prioritize areas that we see the most issues, that we see we need more to invest, and we identify the areas that are of greatest needs, identify the areas that face, higher, number of issues, finding, best, locations, to invest for, some kind of improving policies, projects relevant to any of these, targets of sustainable development goals. And frankly, what I believe is that location-based questions are a lot for SDGs, and it's relevant to the limitations of our resources. So because we have limitations of resources, we have to prioritize areas, locations where we need, intervention, policies, projects, investment. So this brings me to the discussion of today, geospatial thinking, GIS, spatial data science. So GIS refers to geospatial information systems or geographic information systems, and it is used interchangeably with, geospatial analysis and spatial data science as well. It's actually the science of location. We extract location information. We find spatial relationships. We find, relationships between urban systems, on location. We find issues, problems. We identify on place. We identify patterns going on, trends going on place. We kind of find all these, kind of issues, problems, opportunities even on place. And that's the value of GIS, geospatial analysis, and geospatial thinking to answer these kind of questions. And to answer these kind of questions, we need geotagged data, to be able to kind of analyze data, prepare layers of, data in the form of maps, and, overlay all these, layers to, or find, a spatial relationship between, all these layers to be able to kind of propose solutions or identify problems. Now, examples of the works that we have done, examples of the works that we have done are listed here. I don't know whether I can change this a little bit. Okay, so for example, I just want to move this so that I can show you better the title of these papers. So geographic information systems to, find, for example, the best locations for renewable energy zones. This is to address, SDG 7, and, finding a spatial temporal relationships between, the locations of COVID-19 cases and also the locations where construction workers live in Sydney and Melbourne. This is relevant to, good health and well-being in, in SDG 3. Or, this is relevant to SDG 7, spatial analysis, interactive visualization, and GIS-based dashboard for monitoring spatial temporal changes of hotspots of bushfires. And these bushfires usually are coming from, are as kind of results of climate change or global warming happening in, in New South Wales. And this is also relevant to, sustainable cities and communities, resilient cities, SDG 11 plus SDG 13, which is climate actions, SDG. And also, another work we, also conducted relevant to, finding the influencing factors of bushfires using, 40-year spatiotemporal bushfire data. And whatever we produce is about location. Where are the locations we have most problems? We have to prioritize. So, for example, in this, in this paper published by my PhD, work by my PhD student and myself, we wanted to know where are the locations where we see, a higher number of COVID cases and the locations where construction workers live. And why this is important, this was important for us, because, in construction industry, vaccination was not mandated in, in Sydney, Melbourne, Australia. And one of the assumptions we had was that, we think that in areas where we have, more construction workers living, because many of them, kind of don't like to be vaccinated, we probably have, more kind of COVID cases. And we wanted, to see whether we can really find, special relationships. And if there are special relationships, where are the locations of these special relationships? So these are kind of questions we are, answering using, spatial thinking. Another, paper that we worked on is about a spatial analysis of, kind of spatial analysis and monitoring spatial temporal changes of hotspots of bushfires over 100 years in New South Wales. We had rich data over 100 years in New South Wales, bushfire data, and we analyzed all these data, all these geotag data, to understand whether there are new hotspots of bushfires and whether they are close to settlements, and how many settlements will be affected by these new hotspots. If, for example, we know where are the hotspots of bushfires, recurring bushfires, people may know where are these areas. They may avoid close build development close to these areas. But are there new settlements that are overlooked in terms of being prone to bushfire problem? So these are the kind of questions we answered. And in relation to SDG 7 clean energy, we also kind of criticized the site selection by New South Wales government in terms of proposing best locations for renewable energy zones. And the discussions we had was that some of the data layers that should be included in these, for finding best locations for these areas are overlooked by, government. Even they have used, GIS to find the best locations for these areas, but still we think, there are other layers of data that should be, included. And again, it's about locations. For example, this is, the kind of general, the kind of broad area where we found, suitable for, New South Wales renewable energy zones, but the areas proposed by government are not in these areas. They are in other areas propagated in New South Wales. So nowadays we also are working a lot on the intersection of GIS and or location intelligence and also artificial intelligence, AI algorithms. And we work with our researchers on this domain of Geo AI. So we coming back to the topic of bushfires, we also had 40 years of data, geotag data of bushfire and influencing factors on bushfires, and we wanted to know what are the most influencing factors of bushfire in New South Wales. And again, it is about where are these areas and what are these, for example, influencing factors. And we found we simulated some of these patterns of bushfire, and you see, for example, these are some simulations, and the software was developed by CSIRO. We used this software for this paper. So these are all kind of papers, works. We are trying to better understand the location, better understand the problems happening in location, and these are all possible by having a kind of geospatial thinking, and also geospatial methods. And how climate change impact or climate change induced natural disaster impact on coastal changes. And using before and after a storm 3D data, we can understand how much is the erosion, how much is the volume of erosion. For this kind of analysis, we need Geo AI algorithms, and we can also use some simple algorithms in GIS, but the accuracy may not be that accurate. So we also worked on another interesting paper published by my PhD student. I don't know whether I can share that paper. Okay, this paper is here. So we also worked on this paper with my PhD student on data-driven net zero carbon monitoring and understanding the importance of these technologies, the technologies such as geographic information systems, building information modeling, which is again another special method, but in 3D, remote sensing and artificial intelligence for sustainable and resilient cities, which is relevant to SDG 11. And we found these, opportunities from these technologies, detecting, using these technologies help us to detect the areas of concentrated problems to be prioritized and focused on. We can identify spatial and temporal patterns of success or failure. And further to these, we can predict the success or failure of strategies or policies. And also, in another topic that I worked, if, for example, we have, kind of advanced remote sensing data, such as, LiDAR data, which is 3D data, we can see how cities grow over time. Do we have more vegetation clearing in cities, or we have more built up areas in cities? And if we have more vegetation clearing in cities, then this means that we will have higher urban temperature, higher effect of global warming or urban heat island effect in the future. We have to be prepared for these kind of impacts of more buildings or vegetation clearing on our cities. So these are kind of works we have done relevant to these technologies for SDGs. And also, further to this, we also worked on, geo-design workshops. This Global Geo-Design Challenge is led by Carl Stenz, who is the professor emeritus professor in College London, University of College London. And there are, as we see, there are many groups, participated in this Global Geo-Design Challenge, and we are the only, group from Australia. In this, Global Geo-Design Challenge, we wanted to know how we can mitigate or reverse the rapidly accelerating upward trend in global temperatures in a specific area in Sydney, which is called Sydney Central District, by 2050. And it is very important, by 2050, how we can plan, how we can, think about new policies, good policies, climate actions. And this is exactly relevant to the climate action SDG. And we wanted, we explored, we worked on all these, urban systems, to kind of find out where are the locations of intervention policies. So we worked, with the students, in this workshops in our classroom, in our lab, City Antiques Lab, which is City Futures, center, research center lab. We worked with the students, and finally we added all the beautiful maps of ideas students proposed for tackling with these with these issues in a story map, where we had interactive maps, and also we included all these projects, plans, ideas on this kind of maps, where are future urban growth planned, and whether this planned, for example, future urban growth in yellow is affected by bushfire, as you see the pink, and affected by flood in blue. So these are the kind of work we also worked in classroom with our students to help them kind of develop their geospatial thinking relevant to the problems and solutions we can provide for achieving some targets of SDGs at some level. We are not claiming that we are doing we can achieve all the targets 100%, no, but we are teaching them actually how we can kind of use this geospatial thinking to understand how is the current situation working, how is the current situation, and how we can propose, and on which locations we propose for best solutions we may have for tackling climate change, or decreasing the temperature by 2050. And as you see, these are all the maps created by these innovative and creative students. I have added their kind of names here to give them credit for the great work they've done in this geo design workshops. And yes, this is My final message that, why geospatial thinking is important, because I think it helps us to identify the locations where we need the, intervention policies, where we need, projects, where we need investment, where we have, how we have to allocate, resources, how we have to allocate investment. So geospatial thinking helps us to identify those locations for investment, for allocating resources towards achieving, SDG targets. I'm sure thank you very much, everyone, for, listening. I hope I have given you some, ideas of the kind of work we are doing here at UNSW in terms of geospatial thinking for achieving SDGs, especially SDG 11. Any question, everyone?
Thank you, Dr. Sarah, for your very detailed information and presentation. I think we will leave the questions for the Q&A session at the end.
Okay.
Yeah, I will.
Thank you very much, everyone.
Thank you too, Dr. Sarah. So next, our final speaker is Dr. Vinod Velu. He is an associate professor at the School of Earth, Ocean and Climate Sciences at the Indian Institute of Technology. He is an accomplished atmospheric and climate scientist, and he's committed to advancing the understanding of complex environmental interactions. His research primarily focuses on the impact of urbanization and atmospheric aerosols on climate systems, with particular emphasis on the Indian monsoon. Employing an integrative methodology, his work encompasses ground-based observations, satellites, remote sensing, and advanced modeling across diverse spatial and temporal scales.
Thank you very much, actually, for providing me this opportunity. So I'll be talking about urbanization and climate change over rapidly growing Indian cities. But I took the liberty, actually, after seeing the breadth of different topics that is being covered, I thought maybe we will also add some more aspects. So we had done some work on aerosol pollution also over India. So we thought, okay, let us just include that as well. And then I changed the title, took the liberty and changed the title to Urbanization, Aerosol Pollution and Climate Change over Rapidly Growing Indian Cities. So this is a work which is done by one of my students, Soumya Sethi. So he has completed his PhD and then now looking for postdoc opportunities. So this is about us. Before going into the details, I'd like to introduce myself, the kind of work that we do. So we basically look at atmospheric aerosols. So that is our primary area of interest. But then we apply that understanding about atmospheric aerosols on how it has an impact on the Indian monsoon, and then how it has an impact on the regional change, especially related to the surface temperature changes over the whole of Indian region. And then we also do some aspects related to the urbanization. In the recent times, we have started doing. So today, what I'll be presenting will be a couple of papers that we recently published in this domain. Then we also look at regional air quality, especially over Indian region. Main focus area is in the Indo-Gangetic plain in the Indian domain. And recently, we have also started looking at how these aerosols can have an impact on tropical cyclones dynamics. So these are the wide area of things what we are working on. So now coming to this very important topic, a lot of discussion nowadays is happening around climate change. But if you look at the climate change discussion itself, it has evolved over a period of time. So from very simple, just whether human activities are leading to climate change, to the latest report, soon reports will be published where initially they tried to look at climate change as a global problem which globally collectively we can solve. Later now they have realized that they have come to a stage where urban areas are the ones which are actually driving these changes. mostly about 70-75% of emissions come from urban area. So if we attack these urban regions, and if we try to address that problems there, then probably we might also have a solution for the climate change problem. So what Professor Sara was talking about, the SDG goals. So we actually are interested both in SDG 13 as well as SDG 11. More not as such from SDG point of view, but trying to understand some science aspects related to that. So urbanization in recent time, it is a serious issue. If you want to understand why it is so complex and it's not sustainable, we just have to know one thing. If you look at this urban area, how it has increased in the recent times, in certain areas, urban. If you look at globally, we have almost doubled. The population has doubled in the period between 1980 and 2010. But if you look at how much, the area we have made some modifications in some way or the other, then that area is about 8 times. So you can imagine that the population is growing at a slower rate when compared to the impact that we are having on our surrounding environment. So that is the reason why actually sustainability is a very important thing that we need to look at. And if you come to India, India today is among one of the fastest growing major economy in the world, growing at a rate of about 6 to 6.5% on an annual basis. And if you look at how this urbanization itself is growing in India, from 1950, it was about 17-18% at that time. Today, it's about 34% also. So still India is not an urbanized country. We still are a rural, supported country. Most of our economical activities happen in the rural, but we are very, very fast, approaching, that 50% target in the next another 20 years or so. So this is urban area, and the issues related to it will be a major problem for India in the coming decades. So if you look at how they have an impact, most of the studies, if you look, at least from an Indian perspective, we see most of them, they look at urban studies related to urban heat island. So there are a lot of studies. They take satellite data and then try to understand how the heat island hotspots are changing, how the heat island itself is, how the intensity is changing, and they do multi-city work related to it, which can also help policymakers in making decisions where to actually put the resources, so that they can also address this SDG requirements. But in the recent times, there are also studies where people have started looking at this urban aerosol pollution island, but that is a very rare kind of area. Not much studies are done over India, especially. The reason is that availability of data. So if you take even satellite data, the very high quality satellite data related to especially particulate matter, for example, those retrievals are not really available. So we have to depend on proxies actually to do it. So this is a problem. But somehow we have to use whatever available data, and then we have to address both these problems. Only then we can actually address this issue. So if you look at urban heat island studies, it's a very, very old area which has started in the early 18th century onwards. People have been working on this, and now there is a lot of proliferation of urban heat island related studies. It may appear sometimes when we look at the number of publications, and that we know a lot. Now the question is how we can actually utilize this. So Professor Sara was mentioning, how that geospatial data actually can be used for SDG, addressing many of the SDG problem. And earlier, Professor Vasilakis, she was mentioning about, ground-based measurement, because that is the key, because observations is very, very essential. We may get data from the remote sensing equipments, but then always we need to validate it. So from science point of view, very, very important that we include ground measurement, then satellite data sets are very high resolution. And then we also, what I'm going to talk now is actually we can't.
So unfortunately, Dr. Velu, I think he cannot connect anymore. Pretty unfortunate unfortunate, but it happens. So we will go straight to the Q&A section. So if you have any questions for our two present speakers, please leave it to the Q&A box. So this is the last call and last chance to ask any questions. So there are no other questions. I want to thank you all for joining today's webinar. And I hope you found the discussion insightful and valuable. A big thank you for our speakers and for sharing their expertise and experiences, and to everyone in the audience for your time and appreciation. We look forward to seeing you at our next session.
Thank you very much, everyone. Good to see you.
Yeah.
Bye.
Okay, have a great day, everyone.